I was just asking about you. All right, does anybody, how did the first homework go? Good? Well, we'll let the grader tell you. I'll have to talk with him. So what I'm going to do before we start new stuff is I'm going to review the old stuff to hopefully make you feel comfortable. Did anybody use the videos? Nobody did? All right. So, any questions on the homework before I do my review? No? All right, yes? Uh-huh. You mean a wire?
A wire.
Yeah, I'm going to do some examples. I really want to drive this home because we're going to use it the rest of this semester, all right? So, first thing, let's do some review on some of the stuff that you should have. The first is, actually, let's change colors here. Let's use this. So let's do this, and this is current I plus minus V. And so V equals I times R. We're all cool with that, right? And if I go over here and I do current I going from minus to plus, does everybody see I flipped that around? Then V equals minus I times R. Okay, so now I could draw the other two, which basically are the same as these, just flipped. The key takeaway is when the current goes from plus to minus, it's I times R, right? And when it goes from minus to plus, it's minus I times R. Don't think deep, you just need to remember that. Because I could go draw a bunch of other stuff and it'd be the same exact thing as what I'm showing here. But if you remember that, you're golden. So let's do some examples now. I'm going to do all kinds, and then I'm going to try to answer your question about the wire, but then I'm going to ask you to quiz me, and then we'll move on to new stuff. All right? So let's do this circuit right here. I'm going to do an easy one to begin with. And let's just say this is 5 volts and 2K. And let's get rid of all the crap on there. All right, and move this to the side. Now I want this to be easy. What's the easiest thing that you can point to here in this circuit? Ground. Let's label that. So this is 0. Everybody agree with that? Now look at this, and I ask, what is the potential anywhere along this wire? So if I go over here and I say, what is that potential? 0. Everybody cool? What if I go now and I say, what is this potential? Everybody's got that burned into their brains, right? So now I'm going to do something, because when I say what's the potential, it's what's the potential, and I say this point right here, and you say 5. That's with reference to ground. So here's what I'm going to do. I'm going to take some wires. Wires don't have to be straight like I've drawn them, right? I'm going to draw a wire over here. I'm going to draw a wire right here. And then I'm going to go plus, minus, and I'm going to say, what's the voltage across those two wires and why? Okay, whenever someone says voltage across, it's this plus voltage, which is, you just told me 5, minus the voltage on the minus, which you told me is 0. So this voltage is 5 minus 0, or 5. Now, you know I'm going over things over and over because I don't want them to challenge you. I want them to be easy for you. Okay, so now let's focus. You told me there's 5 volts here and there's 0 volts here. So what's the voltage across the resistor? And then you need to ask which way. And this is where students, when you're learning, stutter or pause. They're like, how do I select the plus and the minus? What do I do there? If I define it for you, you know, right? If I define it like this, and I say, what's the voltage across the resistor? You go to the positive side and you say 5. You go to the minus sign and you say 0. And if I call that VR, VR is equal to 5. Does everybody follow that? Okay, so now what if you weren't told which direction to put the resistor on? You don't waste time. You just say, I'm going to pick one. All right, and let's say you pick the opposite way. Let's say you pick plus minus V, let's call it VR2. Okay, so the voltage on the, oh, I'm sorry, plus minus. I did it the opposite way. So what's the voltage on the plus side? Does everybody see the plus side? 0. So I write 0. What's the voltage on the minus side? 5. Wait a sec. You're blowing my mind, man. VR was 5, and then VR2, where I flip the plus and the minus, is minus 5. Everybody's got it, right? So if I have my meter and I check the DC voltage on the battery, I see 5, and then I flip the 2 leads of the meter and I check it again, I see minus 5. Everybody cool with that? Okay, any questions on this? I'm going to do a bunch of examples, make sure it's all burned in. Oh, I got to do one more thing here. Let's go, not to make it too ugly looking here. Actually, you know what? Let me go back in this circuit and draw it on the next page where it's a little clearer. I want to do currents. So I'll redraw the circuit. How was LT Spice, by the way? It's okay? All right. On a big screen TV, it's strange. No. All right. Plus minus 5 volts. And this resistor was 2K. And I came here. And I put the resistor right there. And you told me that this was 5. That this was 0. That this voltage across the resistor was 5. And then I'm going to go back here and I'm going to sketch currents. And here I'm going to ask you, what's the current there? You can wait till the end, man. Don't worry. We don't want you being famous. The guy with the red shirt that came up in the middle of the lecture. All right. Because you know what? You need some reward for driving through that UNLV parking and traffic. Holy crap. All right. So anyway, back on the farm here. So I'm going to sketch this current, and I'm going to sketch it like this, and like this, and like this. And I'm going to be tricky to you, and I'm going to say calculate this current I, and I'm going to point to that wire right there and the current flowing through the wire. Isn't it the same as this? Isn't it the same as this? Isn't it the same as this? But how much current flows in the ground? 0. Okay, so let's pause. So you're telling me there's a current flowing through the ground? Where does it flow? There's that water flow. It goes to that ground. That's just a reference. If you put a pole in your house, a copper pole from the breaker box down into the foundation or a braid, that's what they do. Where does the current flow? It flows down into the ground and into the earth? No, it's got to return back in your circuit. So that current on ground is 0, but the current flowing back on the wire is not. That's why in an outlet at the breaker box, and we'll go through this later in the semester and it'll make more sense. In the breaker box, the ground and the neutral are physically tied together. But then going out of the breaker box, the ground, which is the little hole in the bottom of the outlet, and the neutral, which is the bigger slot, go separate wires. And that's so the hot, which is the little hole, can return all of its juice, all of its power back on the neutral, and none goes on the ground. And from last time, what was the circuit that we used for that? GFI, ground fault interrupter. You know, set, reset, make sure there's no current flowing, that the current on the neutral is equal to the current on the hot. And again, I'm going to cover this more. Okay, so I've asked you now, what's this current? You don't get, and I didn't draw these arrows. You say, hey, this doesn't challenge me. This current's going to be the same as this current's going to be the same as this one, and I could actually draw it like this, and it's the same thing. And so I look here, and is this current going from the plus to the minus? Yes, so I say I equals 5 over 2K, because the current's going from the plus to the minus, or 2.5 milliamps. Any questions? You know we have a quiz today, right? Makes you feel alive. All right, so now I'm going to go and say just the opposite. What if I decide the current's flowing like that? Because I'm deciding, I'm not wasting time. It says calculate the current in the resistor. I pick a direction and it's going to be right. Doesn't matter, because if you wanted it the other way, I just negate the current that I calculated. So, okay, I got this current. What is that current? It's going from minus to plus. So it's minus I is 5 over 2K, or I, in this case, let's call this I2 just to be different, equals minus I equals minus 2.5 milliamps. Any questions about that? Does it make sense? So when I give the quiz today, no one's going to be challenged, right? Yeah, we'll see. You always think, you know, the professor's going to trick me. I'm not trying to trick you. I just want to make sure you did your own homework. All right, no questions on this one because I'm going to do the same problem, but I'm going to change it up a teeny bit. I'm going to do this. That bad, huh? If I got a phone, I can define anywhere I want, and the phone is ground, right? If I have a battery-operated circuit, I define ground wherever I want. If I want to ground the positive terminal, I can. One thing you can't do is if you define ground for this building, the next building's going to have a different ground, and you can't run wires between the buildings unless you run them through some isolation like a transformer. All right, we'll cover all that later. So tell me what to do first here. Let's write the ground. And then what's this voltage? Minus 5. Okay, let me ask that. Here I am sitting here on the ground. Am I going to go to the battery? Am I going to go uphill or downhill when I go from plus to minus? Downhill. If I'm going downhill, I got to be at a potential lower than ground, so that's why I know it's minus 5. What's this potential right here? Minus 5. So what's this potential here? The way I've written it, the voltage across the 2K. Minus 5, the voltage on the positive, minus the voltage on the ground, or minus 5 volts. What if I did it the other way? Well, without doing any thought, if I just flip the plus and minus, what do I know the answer is? 5. But I'm going to do it anyway. Voltage here is 0 minus the voltage here, which is minus 5. That gives me 5 volts. Yes?
When you start with a positive, you don't change the sign.
Yeah, so if, right, if I have this, and it's VA, VB, then the voltage across here is VA minus VB. If I do it like this, then this voltage is VB minus VA. The one you define as the positive when you're saying the voltage across is first. Now, I'm picking which way unless it's told to me, all right? Everybody got that? I've taught this a lot of times, and I know that's always an issue. Which way do I do it? Let me spend 5 minutes on the quiz and then waste it. It's really easy, all right? All right, what am I going to do next? Currents. Okay, so which way do you want the current? I'll let you pick. Why don't I say find the current flowing like this? Sure. I just pick the direction. Which way is the current flowing in this resistor? In this direction. It's like this, it's like this, it's like this. So pause. If I give you on the quiz that circuit and I pick one of those arrows, does that confuse you, or do you just automatically draw the arrow where you like it? You go draw the arrow where you like it and makes you feel good and you don't worry about it because it's the same current flowing in that circuit. Okay? All right, so I got my current. I pointed here, you went up and said, screw that, I'm putting it up here. Okay? Then I say, what's that current? Well, you just told me the voltage from plus to minus was -5. Is the current going from minus to plus or plus to minus? Minus to plus, so I use this one, right? Yeah, and then I say -5 equals minus I times 2K, or I equals 2.5 milliamps. Any questions on that? Is this useful? All right, I don't want to be boring you. If you're like, no, I already know this, then I'll move on. Let me do one other thing unless you don't want it. Questions? Everybody's got this. I want everybody, what's my goal in this class? Everybody gets an A. Please. I really mean it. And, yeah. Anybody not follow anything? I know you don't want to ask questions in a big group, but I'm sure if you have a question, somebody else will have a question as well. You want me to spice it? Few people say yes, so I will do it. Okay, so I will take a picture here, and I will go, and then let's go start this. And let's go here. Did anybody use this folder of Spice? No? All right, that's good, I guess. So we have let's do this last one. We have 5 volts. Let's get the big hand here, grab it up there, hit fit. What happens if when I calculate my current, it's not 2.5 milliamps as I've shown right here, but something different when I look at the current through the resistor? Flip the resistor right on. I had one student a few years ago. That student could not, well, how do you, I mean, it was like a really big deal, and I'm not understanding why this is an issue. So anyway, but people get stuck on different things, so let's call this 2K. And let's call this, let's slide this over a little bit. Let's name this node. How about we call this VBAT? And then let's do a transient instead of an operating point just to be different. And let's go for 1 second and hit fit and then refresh your memory. This node is -5 and the current flowing in this direction is 2.5. Now, I'll hit run, and then I'll plot VBAT, and you see -1.5 just like we said. Now notice how when I put my cursor over the resistor, oh, is it 5? Oh, yes, thank you. All right, run, that's -5. Notice how when I put my cursor over the resistor, it tells me which direction that the resistor or Spice thinks the current's flowing. Is that the same direction as I have right here? No, so you know what I'm going to do? I'm going to get the big hand out. And this is why when you do a dot operating point versus a transient, with the transient you can see which way the current is defined, and OP you can't. But at this point probably OP is better because they're more concise. Just flip it around and show the right answer. And let's actually, you see the right 2.5 milliamps. Let's go add plot plane and then drag this up and then hit save. Why this? So when you go to simulate it tonight, it's all working. Any questions there? Everybody's good on this. So when I say voltage across, or what's this voltage in the rest of the semester, you're going to be, I got this. All right, let's go do a circuit with more than one resistor. How about let's do one with a resistor and a couple of voltage sources? Oh, crazy. All right. And today's homework was doable. All right, so let's do this. Yeah, let's just do 2 voltage sources first. So I got a question. If I draw a battery, like I've done this top one, and I say it's minus 3 volts, I'm learning and I don't like negative voltage sources. I like positive voltage sources. Tell me how to rewrite that with a positive voltage. Flip it. Isn't the voltage here to here the same as the voltage here to here? Let's prove it. Someone tells you, prove it. I'm going to draw a plus here and a minus there. V plus minus V minus by definition is minus 3. V plus, let's write the pluses the same way, minus the V minus is backwards from what we have here, minus 3. Any questions? I got a question. If I have a current flowing and it's 1 milliamp, and then in the same exact spot, I define the current this way, what's the current? Okay, everybody's got these, right? Okay, so this is what's called Kirchhoff's voltage law. It's where you sum the voltages around the loop, and when you get back to where you start, they go to 0. So we're going to do this with me running here, and I got my little running shoes on. And I'm going to start running. I'm on 0 here. And the first thing I do is I go to this voltage source. Am I going uphill or downhill if I go from plus to minus? Downhill. So what is the first voltage I write after I get up here? So I've just run from ground up to here. What is this voltage? If I write the voltage right here, what is it? Minus 2. I'm trying to be easy here, trivial, not to make you lose concentration. Everybody's following that, right? I'm going to keep running, and I'm going to run over to here. And looking at this plus and minus, I'm going downhill, but I'm going downhill by minus 3. That's the same as flipping it around and going uphill by 3. Okay, this one's going to blow your mind, right? So I'm over here, and I say, all right, I'm going to run, and I'm going to go downhill from minus 2 to the other side, plus to minus. I'm going to go down, minus. So I'm going to put the minus there, and then I'm going to go down by the voltage source. What is the value of the voltage source? Minus 3. So really, I could think about this, and I could be with the voltage source like this. Isn't that the same thing? So I'm really going uphill by 3 because I'm going down by minus 3. So if I ask you now, what is the voltage right there? It's 1 volt. And I could get that by adding those two together. Making sense? Okay? Now, here's the thing. I don't know. This isn't a voltage source here, right? And I don't know what the voltage across that 1K resistor is. So what do? Nope. What did I say? I keep telling you, don't be afraid. Pick a current, say, what do I do at this point? I don't know what the voltage drop is. Why don't I, just for the heck of it, do it real slow and call this VR? And I could be lazy and I could go, oh, I'm going down to by VR, so minus VR equals 0, because I'm back to where I got started. That's Kirchhoff's voltage law. KVL. Oh, we'll say that a few times this semester. And that says when you go around a loop, the sum of the voltages has to sum to 0. When you start where you start, when you get back to where you start, it has to be 0. All right? I could make a joke about age, but I won't. All right. So tell me what to do. Well, I got a question. Before you tell me what to do, what if I picked VR the other way, where it's plus minus? Then it would be plus VR. And the value I got would just be negative of the way I pick here. I'm not afraid. I pick and go. Okay, but I don't know what VR is. How do I know what VR is in that circuit? Well, I do know what it is because it's 1 volt across there, but let's say I didn't. what's the law that I have to use at this point? Well, keep it simple. May I only ask simple questions? What's the law? No. What's the law? Ohm's law. It's not KVL, we already did that. Ohm's law, and let me sketch that on here. That's I, and that's VR is equal to I times 1K. Now in this circuit, I know VR is 1, it's pretty easy, right? But let's say it's not, because I like making things hard. Okay? So I go over here and I write 1 minus I times 1K equals 0. I equals, move this to the other side, 1 over 1K, which is 1 milliamp. And then VR equals I times 1K, which is 1 milliamp times 1K, which is 1 volt. Now I've solved for everything in the circuit. Any questions about that? Does it make sense? Okay, so let me ask you this. If I change the order of those circuits, of the elements in the circuit, do you think it would change the voltage drop across the 1K? If I switch the order, like I put the 1K at the top and move the -3 over, do you think it would change the voltage drop across the 1K? No. But let's prove it. But before I move on, I'm not getting any feedback from you. You're like, are you following? Yes?
Technicalities, since the volts are like in series, can you just add them together?
Yeah. So the sum of the voltages, that's Kirchhoff's voltage law. The sum of the voltages across or around the loop is 0. So here, let's pause and answer that. So I'm gonna, instead of drawing these components, let's just do black boxes. And let's say I got a black box like this, and this is plus minus, let's do it this way, -2. Everybody agree with that? And then this is black box. Let's flip it around and say, if I do this right, plus minus 3. Oops. And then let's go, and now plus minus 1 volt. And if I did that right, these all are going to sum to 0. So 2, let's see. No, I got something wrong here. Oh, this one should be. Oh, no, I had it right, but let me make it clear. So this would be plus minus 3. And so when I sum all of these together, the 3 equals the 2 plus the 1. So I look here and the current's going in to the minus, and here that current's going into the plus. Everybody see that? All right, so if I look at that, what I'm going to do is I'm going to, let me do this problem again and then we'll come back, all right? So before I leave this, everybody sees the voltage around the loop sums to 0. Okay, we'll come back to that. Well, I'm not going to come back, I'm going to do it again. So I have this. And do you all agree with me that this circuit is the same as this one? I've just moved the resistor up here and moved the voltage source down. Okay, and so what is VR in this circuit? Okay, so I'm going to define the VR like this. And I'm going to define the current like this. And I'm going to ask, what's the current? Let's do this a different way. What's the current through, and then we'll do it KVL to show all this voltages sum. Quickly tell me what the current through that resistor is from your homework today. Okay, wait, let's back up. I skipped ahead too many steps there. What's this voltage? 0. What's this voltage? What's this voltage? Let's just call it V for now. What's that voltage? V. Okay, if V is -3, what's that voltage? It's the voltage across the resistor, VR. The positive side minus the negative side who follows? So now, wouldn't I be the voltage across the resistor, VR, divided by 1K or 1 milliamp? How does that compare to what we got here? It's the same. How does the voltage drop of 1 volt across VR compare to what we got here, just rearranging the order of the elements? Same. Any questions? You know what? Let me look at today's quiz. Let's see how challenging this is. You know what I'm going to do right now? I'm going to apologize to each and every one of you. This is not going to challenge you, and I feel bad. At least that's what I want. All right, let's do the KVL and show the voltages sum to 0 again. And I'm just going to put this as 1 volt. All right, because we've calculated that a couple of ways. So here I'm going to start. I'm going to do this twice. I'm going to start here at ground again, and I'm going to run. Actually, why don't I run this way instead, because it doesn't matter. I'm going to run over here. What do I get? Am I going uphill or downhill? Forget this for a moment. Uphill by -3. So why don't I put plus, because I'm going uphill by -3. And then here, I'm going minus to plus, so am I going uphill or downhill? Uphill, because I'm going from a low minus to a plus, so I'm going uphill, so +1. And then here, I'm going downhill. I'm sorry, I'm not going downhill. Here, what am I doing? Going downhill or uphill if I'm going minus to plus? Uphill, right? But if I'm going uphill, I'm going up by what? And what does that sum to? Yeah, what law is that? Yes, you should know. All right, any questions on that circuit? Yes? Yep. Why don't I flip the way I've defined plus and minus around and do this problem again? See, it'd make me laugh if you said I'm confused because of poor instruction. No one else thinks that's funny. I do. Because I've been through poor instruction. All right. Not here. All right, let me see if this answers your question, all right? We'll flip it around. So you agree that 2 volts, and then here, and then I'm going to have minus plus VR. And you want me to leave the current going in the same direction or opposite? Same, all right. Same direction. And then I'm going to come over here, plus minus 3 volts, come back down. And then I'm going to put the circuit up there so you can see I'm not cheating you. It's like a card game, right? Magic trick. Not cheating you, just flip the VR around. So in this case, what's the VR going to be? And no one's going to come to my office hours and say, I'm confused. In one place you calculated VR as 1, and the next one you calculated it as -1. Well, I defined it different in this circuit, the opposite of this one. All right, so I know what the answer is. Let's go from there. Any questions about this? Yes? Well, I don't know. Let's do some examples in a moment. We'll see. Let's pick them crazy. We'll do them different. How's that? Okay, what am I going to do first here? Because I'm learning. Ground. There's my 0. I know that's 0 volts. Then what's this voltage? -2. What's this voltage? Okay, is anybody challenged by this at this point that will admit it? Okay, so I want to calculate this current. Or I want to calculate VR first. What is VR? This is important. What is VR? Well, I can't just write answers down. That would be good. My life would be easy. It's the voltage on the positive terminal, the -3, minus the voltage on the negative terminal, which is -2. And in that direction, what is it? -1, yes. And that's opposite of what we calculated in the previous circuit. So now, is the current flowing from the minus to the plus or the plus to the minus? So which Ohm's law do I use? I'm learning, so I'm going to write this down and not try to remember, right? And so I look, hey, that's -1 volt. R is 1K, so I get I equals -1 volt over minus I equals 1 volt, -1 volt over 1K, or I equals 1 milliamp. Anybody agree with that? Well, wait a sec. Here you calculated VR as -1. In the previous one, VR was +1 because you plopped that. But the current you calculate here is 1 milliamp. The current you calculate in the previous one was also 1 milliamp. Well, they're in the same direction. They should be. If I flipped it around, then it would be -1. Any questions? Yeah, you can pick the current and then solve it, and if it's actually flowing the other direction, you just get a negative number. Did that answer your question? Okay. I don't want you leaving saying he didn't answer my question, which could be the case. All right. Let's do some more circuits with resistors. All right. Let's look at tomorrow or homework on Wednesday, because unfortunately Monday's a holiday. All right. Ooh, that looks fancy. Yes.
So we tried to solve that one on LT spice.
And it went crazy?
Yes.
Really? Am I giving you crazy problems? Why don't I do this one? Does that sound good? Let's see why LT Spice is not liking it. All right, I can't see, so let me sketch this first. 2K. So when you say it didn't like it, you mean it didn't simulate?
It would simulate, but the way you have between VS and VX, the way you have the battery set up, your negative and your positive terminals, it gives you a VS equals 0 volts.
You think that's wrong?
No.
All right.
No.
Well, if I work this, is everybody going to be disappointed in me? That you have like more time to relax on Labor Day weekend and appreciate labor? All right. I don't want anybody complaining. He gave a homework and then he actually worked it. What's up with that? All right. It's too easy. Kick up. Don't worry. We'll kick up the volume. All right. Tell me what to do here to start out. Okay, so I'm going to write the ground. And then what's next? I think we should do this one a few ways. Wait. What's the next easy thing? What's this voltage? 0. The wire all connected together. What's this voltage? Okay, I'm about to blow your minds. What is the voltage here? Yes, it is, but let's put it a little more concisely. What is it? It's a wire. This is the same voltage all along, anywhere on this wire. And you know, I always tell the students, especially when you're starting to do stuff in the lab, you know, we draw the schematics with straight wires. Wires aren't straight. The wire could go over there, down there, in the ground, up and around. All right, so all along here, this is all ground. We all cool all along here. This wire, it's all 1.5. So if I draw the plus and minus like this, I know this voltage is 1.5 and I know this voltage is 0. So the voltage across the resistor is 1.5. And I could say now, what's the current through the resistor? And I'm going to define, because I'm lazy, the current like this. And then I can write this current as the voltage across the resistor. Do I use positive or negative ohms law? Positive. The voltage across the resistor is 1.5. And the resistor's value is 1K. That gives me a value of, man, this circuit's easy. Okay, so here I am. I'm sitting here and deciding, okay, I'm going to keep running, but what level am I at right there? What's my potential? Okay, pause. Anybody not follow that? Got a battery there. I'm about to run down. I'm about to run downhill or uphill? Downhill, and I'm at 1.5, and where am I going down to? Down by 1.5. And so here, what is that potential? But what is this potential? So what is the current through there? Ooh, I give tricky problems, eh? You pick the current like this, then it would be 0 minus 0 over 2K.
Well, I was just trying to follow your arrow, but yeah, okay. I got it.
Yeah, questions? I don't know. It could be a sensing resistor, determine when this battery is getting low, because as it gets low, it's going to go to 1.4, then this will go to 0.1, and then it'll go to 1.3, this will go to 0.1. Yeah. All right, let's do the circuit again, but before I do, this would be a circuit I'd put on something like this on the quiz on Wednesday to make sure you did the homework problem. Oh, he did it, I don't need to look at that one. Oh, wrong! Let's redo this problem using a KVL. And what does KVL say again? If you go around the loop, the voltages must sum to 0. And I'm going to do, how many loops do I have here? Well, 2, or if you want to call this one a loop, you can. But it's really not. I mean, you can call it whatever you want. Vx and Vs. And then I'm going to go around this loop right here that I highlight. So I'm going to go run around this loop. I do a KVL around that loop. And I'm going to start right here. I'm going to start running this way. So I'm starting, so I don't know what the potential is there, right? That's where I just picked. So I go, I'm running around this loop. What's the first thing I write? Am I going uphill or downhill? Then Vs, I'm going to write like this. And Vs is what? Did everybody agree that it's like this? Well, wait, no, stop. If I say this voltage is Vs, what does that mean? That's the voltage relative to ground. So Vs, if I say that's the voltage Vs, that's the plus terminal, and what's the minus terminal when I do my probe? Ground. So right there, I know if I call that Vs, that's got to be across the resistor because it's going to ground. Do you know where else Vs is, plus minus? It could be a wire from here to a wire from here. Is that different than what I drew over there? Vs is where the plus is, ground is where the minus is. I just draw my wires. I can draw that anywhere. I could draw it right here. Yay? Okay, so I go over here, and then I go uphill or downhill with Vs? Downhill, Vs. And then I'm running over here, long boring distance. Here I'm running, listening to my mud vein or whatever. And then I come up here, and am I going uphill or downhill? So what's 1.5 minus 1.5? And that I solved using KVL. Any questions? Making sense? Let's do it a different way or a different loop. Yes? The what? No, depends how. This one actually is, but it's through a resistor. It's just how you, if I take a battery and I put it into a circuit, I can put it anywhere I need to put in my circuit, right? So, it's just a battery. You know what a battery is. You've changed batteries, right? Yes?
So the resistor on the left doesn't really matter?
No, it's part of the circuit. If this changes, then so will the current through that resistor. How about on the quiz, I take that first problem and I change this resistor to, or I change this voltage source to 1.3 volts. I'll get a different VS. What will be the VS? 1.5 minus 1.3 or 0.2. If you understand this problem, you're not challenged. Man, I'm kicking ass in this class. I got 100%. I'm not trying to trick you. I just want you to know what's going on. What a novel concept, huh? All right, let's do another loop. Wait, before I do, are there any other questions here on this one? Let's do this loop right. This was 1K. Let's do this loop right here. And let's go this direction. And I'm going to start running. Start at the same place. And where do I go? I'm on this loop, so I come down here. And what's this voltage? Please answer if I know I'm doing a good job teaching. No. Oh, yeah, that is. But I mean, in terms of Vx, what is it in terms of Vx? It's Vx. Because I can come down here and put a terminal here and here. That's Vx, right? Okay, so I'm going to go there, and I'm going to call that Vx, and I'm going to go, am I going uphill or downhill? Downhill. So Vx, and it is minus, because I'm going downhill. Then here I am, and I'm going uphill. Am I going uphill or down? I told you the answer. Am I going uphill or downhill? Uphill. Looking good? So what is Vx equal to? Oh, I could have seen that by inspection, but I did it using KVL. Any questions? What's that? Oh, if I want to find the current, what's the current through the resistor? That's a good question. Let's not do math on that one. 1.5 over 1K, 1.5 milliamps. If Vs is 0, what's the current through the 2K resistor? 0. If I ask, then what's the current flowing through this 1.5 volt source? Wait. Man, I'm serious. When I look at circuits, I think like water flowing and pressure. There's no current flowing through here. How much current's flowing through here? 0. There's no water flowing in that pipe. So you start troubleshooting some plumbing issues, you'll probably have nightmares. So the water, I'll tell you about the 3 rules of being a plumber some other time. The water through here is 0, or the current through here is 0 because the current through here is 0. So you just told me the current through there is 1.5, so how much current is supplied by the 1.5 volt source? 0 goes there. 1.5 goes there, so what's flowing there? 1.5. So, we're going to learn a new Kirchhoff's law called the Kirchhoff's current law. And we just covered it. It's pretty exciting. It says, or KCL says, current going into a node equals current going out. So current going this way, you told me is 0. The current going this way is 1.5 milliamps. So therefore, the current going this way has to be 1.5 milliamps. Okay, so when you get home tonight, and I've posted the notes, take this piece of paper right here, take this one, print it out, and put it with some Scotch tape on your fridge, and then tell people you had a bad day and tell them to look at the fridge. Say, there's me. All right. Any questions on this circuit? We're going to do some more. It's good? How's the pain? At least it's not a million. It's a million! No questions on this before we turn the page. Question?
No, it's just, I think it's just out the spice being weird. It was, when I was doing these problems on the first homework, I would have a negative current for the power source.
Wait. We covered that last time. How does SPICE define positive current flow in a current source? Plus to minus. Remember? And then we're defining it for Ohm's law as plus to minus as positive and then flipping it around. See, that was good. You brought that up. Refresh that. All right, let's do another one. Took the GRE, which is the exam you get into grad school. She's a civil engineering professor at University of Colorado Boulder. They asked her this question, okay? So I want you to make sure you can answer it, because even people that teach math in high schools, I'll ask them and they'll go, And this is related to parallel current sources. And I told her this right before she took the exam, and it was on there. And she said, Dad, that was on there. And I'm like, yep. All right, if I have a swimming pool, and I can put a hose in there and I can fill that swimming pool in 20 hours with that one hose. And then I have another swimming pool or another hose, and I can fill that swimming pool alone with that hose by itself in 10 hours. How fast can I fill the swimming pool with both hoses going at the same time? Now, don't make me cry by saying 15, because you can do it with 1 and 10. So you know the answer has to be less than 10. So I'm going to show you how to do it, and then we're going to talk about parallel connected resistors. All right, so if you look, I can fill one pool in 20 hours. If I have another hose going, I can fill that same pool in 10 hours. But going together, I can fill one pool in the total time, which I'll call T. Everybody follow that? So now you're going to remember this, right? Because this problem and variations are very common. And so if I solve for T, and I do that, should I feel the pain? Yeah, I'll feel the pain the first time. So what do I do here? Common denominator, and I'm going to be sloppy. I'm going to write 10 over 20 times 10 plus 20 over 20 times 10 equals 10 plus 20 over 20 times 10, or T equals 20 times 10 over 20 plus 10, or 200 divided by 30, or 20 hours. That is the time. Pretty good? All right, so now, if I take resistors and I put them in well, actually, let's do this. We covered this last time. If I have two resistors like this, R1 and R2, and I want them to be a single resistor, what is it? Yeah, just add them together. It's easy, right? Everybody cool with that? But what if I have two resistors, and let's call it R3 and R4, and I take those two resistors and I want to combine them into a single resistor in parallel. So I'm going to do this one time, but it's the same exact answer. This resistor total is R3 times R4 over R3 plus R4. Just like it was 20 times 10 over 10 plus 20. R3 times, does everybody see the equivalent? Okay, I'm going to prove it though. Let's call this V. And let's call this current I. And let's use Kirchhoff's current law. So I want you to tell me, what is this current right here? We'll call it IR3. Okay, let me ask a simpler question. What's the voltage drop across R3? It is V. You know, I thought I brought a bottle of water. I'm going crazy. Did I leave my water? Oh, there it is. I knew because the instructor was. I need to drink water. You didn't drink out of my water, did you? Yes, I did.
Stay hydrated.
When you talk a lot, you have to. One time I do expert witness work and litigation, and one time I went and did a case in DC, and the lawyers were like, "Oh, you only be up there 10 minutes." And I always learned when you go testify, take water with you because your throat gets super dry from talking too much. And I got up there, and the damn attorneys wouldn't let me get down, and I was there 2 hours, and I could literally not talk, and I kept thinking to myself, "Stupid! It doesn't hurt to take water with you." It was like it started affecting my concentration. It was so bad. And in that case, I ended up being the one that talked the loudest, even though the attorneys on my side, "Oh no, you won't be there the longest." All right. So if I do this, somebody said it's V over R3. And then if I have the other one, it's I equals V over R4. If I ask what's that voltage, what is that voltage across R4 the way I've drawn it? Hey, man, he asks hard questions. Everybody follow? That's if you didn't get that quickly and you're like, I better wake up. Okay? So that's V. So now, if I look, and I'm going to do a KCL here, what is I equal to? Doing a KCL, the current that goes in is equal to the currents that go out. Okay, this is really easy. Got water going into the pipe, splits, the water going out of the pipe's equal to the water going in, right? Got I going in and IR3 and IR4 going out, so what do I write here? Anybody not follow that? And would everybody agree I could write that as I equals V over R3 plus V over R4? This is where I say, do I get lazy or not? And I'm not going to. I'm going to get a new piece of paper. We're going to come back to this. Any questions on any of this? So what is my goal here? What am I trying to do? Combine these two resistors into one resistor RT. So I'm going to go back and actually I probably can do it here. Yeah, so the GRE exam, if you're an engineer, that's the graduate record exam if you want to get into grad school, doesn't have any calculus whatsoever. The highest math is algebra. And so if you take the specific test for a specific discipline, then it gets into the math. But the basic math of the GRE, which is a big part of the quantitative score, is algebra. So, all right. It's like how many credits is a bachelor's degree? How many credits is a master's? See, I didn't know either when I was an undergrad. Master's is only 30 credits. So it's a much, much shorter, fewer credits than a bachelor's. And you're able to focus more. All right, so if I label this current, that's I. Would everybody agree then that I is equal to V over RT? And then wouldn't you agree that I could write this is V over RT is equal to I? And wouldn't you agree I could go boom, 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 and don't I have the same thing as the swimming pool problem? And so then it's R3, R4, etc. So I'm going to summarize this on the next page, but before I do, are there any questions? All right, you guys are so quiet. And we got a few minutes and we'll do the quiz. I'm gonna do one more problem. This quiz is, hopefully it's easy. If it's not, then you can blame poor instruction. So summarizing, if I have resistors in parallel, then the equivalent everybody agree with that? For the case when there's only two, the equivalent resistance is R1 times R2 over R1 plus R2. Any questions? Let's do one more circuit and then we'll get our grade booster. Wait, my grade can't be boosted. I'm getting an A. Just starting out. Here's the circuit, the last one we're going to do for the day. I'm going to do it twice. And I want you to find all the voltages and all the currents in the circuit. You guys do know I scan these notes, right? Everybody's busy copying. I'd be kicking back going, yeah, I'm following. So I'm going to do this problem twice. I'm going to do it the way I would do it if I was working in industry. And the very first thing I'd do is I'd combine these two resistors together. Two like resistors combined together, this is something you need to burn into your brains, is half the value. So 2K times 2K over 2K plus 2K is 1K. So I don't have to do too much math in my head. And then this is a 2K, and then this is a 2 volts. And then I'm going to say this voltage here is Vx. This voltage is Vx. Would it bother anybody if I put the voltage out like this and I went Vx? And now what am I going to use from the first lecture? Voltage divider, two resistances and a voltage. So I get Vx equals 2 times 1K over 1K plus 2K, or two-thirds volts. So what's this voltage? Two-thirds. What's this voltage? 2. Don't lose all the stuff that you learned in this class. Now, what is this current? 2 minus 2/3 over 2K. This voltage minus this voltage over 2K. You're blowing my mind, man. What is this voltage? 2 minus 2/3. Isn't it 2/3, 1 1/3? Isn't that what it is? Yeah, 4/3, yeah. All right, and then what's this voltage here? And how's it relate to that voltage there? 2/3. And what's the current through either one of these resistors? 2/3 volts over 2K. All right, that's the way I would have done it in industry. Let's do it like we're learning. All right, any questions before I move on? Am I going too slow on that one? That was a joke. Not funny. Let's do it like we were learning, and I'm gonna not combine the resistors and all that. And then what I'm gonna do is I'm gonna put my 2-volt source, keeping an eye on the clock, and the 2K. Now I'm gonna go ahead and label this, because we're running out of times, 2 volts. And then I'm gonna come down here, and this was a 2K, and this is a 2K, and then I'm going to ask, what is this voltage right here? What is this voltage? Let's call it Vx again. There's so many ways. Well, I know it's 2/3. I just solved it. Now you understand that I could directly combine these together at 1K and then do a voltage divider, but I don't want to do that. I want to feel pain, because learning is pain. So here's what I'm going to do. I'm going to write the currents in this circuit. First, I'm going to write this voltage. What is this voltage? Now I'm repeating myself. What is that voltage? I don't know. I didn't do that previous problem. I don't know what the answer is. I'm starting from scratch. I'm going slow and I'm learning. Right on. 2 minus Vx. Anybody not follow that? This was hard for me when I was learning. I was like, oh, this is 2 volts. It wasn't really clearly explained that the voltage across would be the plus minus the minus. Notice how when I start out, I label things so I don't go to here and go, and see a blank node. Because I would do that. I'm learning. Okay, what are the voltages across here? Yeah, Vx minus 0, which is Vx. So I'm going to do a KCL right here. I'm going to define my current going like that, and my currents going like this. Why did I define my currents going like that? I want to define positive Ohm's law. I don't need to work unnecessarily. Right? I'm defining it. I'm going to put the plus to minus as the direction of the current. I don't want to throw in there and put negative signs in. That sucks. No, not now. We have to do the quiz, and I don't want you to be late. Okay, so then what is this current? 2 minus Vx over 2K. That's equal to these two currents, which is Vx over 2K plus Vx over 2K. This current's here, this current's here. Got one equation, one unknown. Does everybody see that? I cancel the 2Ks, and what do I get for Vx? All right, let's stop there and do our grade booster. Any questions?